Hello, everyone. Welcome to our OpenShift Commons general meeting. We meet every Wednesday at 12 Eastern Time. And this meetings is all about community and collaboration. So here is where end users, customers, partners, and contributors meet and just discuss and chat about different topics. So here today I have Gerald Nunn who will be talking about GitOps, OpenShift GitOps. So Gerald, the floor is all yours.
Thanks. My name is Gerald Nunn. I am the GitOps Technical Marketing Manager, and today we're going to be going through a basic overview and introduction to GitOps on OpenShift via OpenShift GitOps. And if there are any questions during the session, feel free to ask. I'm happy to respond, so feel free to interrupt me at any point in time. At the end of these few slides that I've got a handful of slides that we'll be going through. Let me just start that off here. It's about 20 slides or so. It'll go relatively quickly. We'll do a short demo of OpenShift GitOps and how it works, and then we can have an open floor in terms of general GitOps questions. I can show a bit of what I'm doing in my home lab with some more complex use cases if folks are interested in that as well, and talk about it at that point in time. So right now, let's start with the slides. We're going to do an overview of OpenShift GitOps, and the first thing to talk about is what is GitOps. It's a term that's been around for a while now, and it's being talked about quite a bit. But essentially what GitOps is a developer-centric approach in the sense that we're using Git, and Git and source control really has its roots in the developer community. But Git itself was actually started by Linus Torvalds, who was looking at it to manage the Linux distributions. You could almost say it's a bit of ops in there as well. But the whole idea really is that Git is going to be the single source of truth for the state of our Kubernetes cluster. So we're going to store in Git all of the manifests and everything that is going to configure our cluster, and we're going to treat all of that as code and have it go through a normal Git workflow. And what we're going to do is have something, an engine that is providing the GitOps capability, automatically reconcile those manifests in Git with the state in the cluster. So the way it basically works is that you've got Git on the left side, and this is your desired state, i.e., what do I want to be deployed into the cluster? Then you've got continuous delivery that's happening here, and this is the GitOps engine, and there are many different GitOps engines that are available out there, and we'll talk about that a little bit more as we go through the slides. And then that will be delivered to be your current state. Now, this is a constant reconciliation loop, which is really nice because anytime I make a change to Git, it will automatically get picked up and potentially flow into the cluster if I have an option enabled in the GitOps engine to do that. Or if I don't have that option enabled, it will automatically flag there's been a change and that the two states are not in sync anymore, or not synchronized, and that they're out of sync, and that remediation is required to get them in sync. The great thing about GitOps and why it is such an improvement over traditional infrastructure as code tools is that it works both ways. Not only does it reconcile from Git to the cluster, it also reconciles from the cluster as well. So if I'm having my GitOps engine manage something in the cluster and I go in as an operator, as a user, and I change that thing directly using OC edit or in the UI, Git will automatically detect that now this is the GitOps engine will automatically detect this is now out of sync. And it can, again, automatically remediate that and put it back in sync, right? So for somebody that used to be consulting, configuration drift was like the bane of my existence between, like, say, dev, stage, prod, and all the other environments that we'd be managing. And this tool would have been a panacea back in the days when I was doing hardcore consulting to deal with that issue. So from a delivery model, when you're looking at it from an application perspective, you've got a couple of different repositories typically that you manage. You have the source repository. So this will be like your Java code, your C# code, or Go code, whatever you're coding in. And then you have a configuration Git repository where you're storing all of your manifests, i.e. the YAML that is representing the state that you want deployed into the cluster. So from a flow perspective, a developer would check in code as normal into your source repository. The CI engine, like OpenShift pipelines, GitHub Actions, etc., would pick that up, build it, and create an image. And at the same time, it can then update the Git repository with that new image reference and have the GitOps engine, in this case Argo CD, pick that change up and automatically deploy it into the cluster. How this happens here between CI And your GitOps engine and this Git repo can happen in a couple of different ways. And really it revolves around whether this is a gated or non-gated environment. So in a non-gated environment, let's say, for example, development, changes would be showing up there automatically, and you can have your CI tool make changes in Git directly without a pull request. But in gated environments, where you want somebody to approve that change, like in a production environment, you can use a pull request so that, you know, a manager or somebody with appropriate authority can review the request and then merge it into the repo as needed, at which point Argo will pick it up and deploy it. So why GitOps? There's a number of benefits that GitOps brings to the table. The first one is the standard workflow. Git has been around for ages. Developers have been working with Git for a long time, and how it works and how it interacts with other tools in the ecosystem is well understood. And it really is a standard approach in terms of managing source code. And we're essentially taking that standard approach and applying it to ops. From a visibility and audit perspective, because all of the changes to a cluster or to a configuration of an application are happening in Git, you have full visibility and audit. No more do you have the question of, hey, who changed this in the dev environment and why did they change it, right? In order to make that change, somebody has to make that change in Git. They have to provide a comment. You know who did it. So you can always go and ask them very quickly and easily what those changes were. And for organizations that are operating in regulatory environments, having a clear and concise audit trail is a huge benefit in terms of meeting those regulatory requirements that many of those organizations have. Similar to that, and part and parcel with that, is that you get enhanced security as well, right? I already talked about pull requests, for example. If you do everything through pull requests in your gated environments, then you have an opportunity to review all those changes beforehand. You can use CI tools or other infrastructure tools to essentially review those changes in an automated way, like do automated testing on it, make sure that everything's going to work before it goes down, so we don't lose, like, you know, half of the Windows systems in our global ecosystem, to point out the latest fiasco that happened a few days ago. So you get a lot of benefits from that perspective, right? You can understand exactly who's doing what and when, and approve all those changes before it gets into a cluster. And then again, going back to the configuration drift allegory that I mentioned earlier, you get the same capability across multiple clusters, right? You can have all of your clusters configured in a very consistent way, and you can be assured of that consistency because the GitOps engine is constantly monitoring those clusters for changes and letting you know those changes have been made and that there's remediation required, or in fact, as I mentioned earlier, automatically remediating those changes as needed. So for folks that are not familiar with GitOps, I usually show this slide just to kind of put people's, you know, fears of change at rest. That GitOps has been around for a long time now. This is not a new technology or a new methodology. It really was coined back in 2016, which is 8 years ago, which in, you know, IT terms is an eternity. It's almost, I feel like that was back when the dinosaurs were still roaming the earth. So it's been around for a long time, and in the CNCF landscape, there are really two core projects that provide GitOps capabilities. One is Argo CD, which is what OpenShift is based on, and the other one is Flux, which we're not supporting, but can be used on OpenShift if you have a preference for that. So again, not to go through this in great detail, but just to show, GitOps has been around for a long time. It's perfectly safe to use. You don't have to feel like you're breaking new ground as an organization if you adopt the GitOps methodology. And we see that as well in the CNCF annual surveys. For the 2022 survey, where they asked about GitOps specifically, we can see that there was widespread interest in adoption in terms of the GitOps methodology for managing cloud native applications and infrastructure. And with like maybe only, 8%, 11% having no interest or not started or not doing anything with GitOps, where everybody else is in various phases of their GitOps journey, right? So again, this is really the de facto way, in my opinion, for managing Kubernetes clusters and the applications that are residing on Kubernetes. So along with GitOps, there are a set of principles in terms of what is GitOps, in terms of, you know, what defines it? What do you need to have in order to be considered GitOps? And these principles were defined by the Open GitOps group, and I have a link here below that you can go and check out these principles. So this is not something that, you know, Red Hat has defined or is vendor specific in any shape or form. It was done by an open consortium that essentially has multiple vendor representation on it. But really the four key principles are: first, your system must be declarative. And by declarative, what we mean is that essentially you define what you want and the system will then make that happen, right? So Kubernetes, one is a declarative system. And one of the reasons why Kubernetes is very successful is because of the declarative nature of Kubernetes, in my opinion, in the sense that, I can just write a deployment YAML and I can say, okay, this is my application, my image, how much CPU, how much memory it needs, give it to Kubernetes, and it handles deploying it into the cluster and figuring out where pods should sit and do all that kind of stuff, right? In the bad old days of automation, I would have to write Ansible scripts or other things to manage all of that across a fleet of VMs, right? So that declarative capability is hugely important, and GitOps is really just building on top of that. Changes are pulled automatically in the sense that as you make changes into your source of truth, i.e. Git, the software agents, i.e. the GitOps engine, will automatically pull those desired state declarations and push them onto the cluster. Your desired state has to be stored in a way that enforces immutability and has versioning capabilities, and this is really what Git is providing under the hood. Git is immutable in the sense that you can go to a commit hash at any point in time and be confident that that commit hash is consistent, i.e. nobody can go in and change things in the past. Obviously, you can make changes in the future, which results in a new commit hash, but at any particular commit hash, it is an immutable system. And then finally, it's continuously reconciled. So the software agents, i.e. the GitOps engine, is constantly observing the actual state of the system as well as the desired state and making sure that the two are in sync at all times. So those are the 4 GitOps principles that are in play and what really is considered a GitOps methodology. And while I'm talking about GitOps engines like Argo CD and Flux, you can certainly do these principles in a variety of different ways. Like, for example, if you want to use Ansible, you could use Ansible to mimic or do a lot of this functionality, provide a GitOps engine on conventional infrastructure as well. All right, so let's get into OpenShift GitOps in terms of what our implementation is on OpenShift for GitOps. So OpenShift GitOps is an operator that is deployed on OpenShift, and really it provides a number of key capabilities. It manages the multi-cluster config management, as we talked about earlier, ensuring that you have that consistency across your different clusters. It provides an automatic Argo CD install and upgrade. So it will install Argo CD instances and manage those for you. And as new versions of Argo CD become available through new versions of the operator, it will automatically upgrade those versions for you, right? So it gets full lifecycle management of the Argo CD installations on your cluster. We do provide some opinionated GitOps bootstrapping. Dan, you had a question?
Yeah. Since it does multi-cluster management, does it require you to have the ACM subscription?
No, you're not required to have ACM, but ACM does provide additional benefits over and above Argo CD. And I actually use both together in my home lab to manage all of my different clusters. And I can show you a bit of that at the end of the presentation if you want to remind me. I don't mind going through that in a little more detail.
No worries. Okay, thank you.
Yeah, no problem. But they're very complementary, ACM and OpenShift GitOps, aka Argo CD, and they work really well together. And then in deployments and environment insights with Argo CD, as I mentioned earlier, you can see when state has changed in the different clusters. It's very visible that things are out of sync and require remediation. And alerts also get raised out of OpenShift as well to provide that information more proactively through Prometheus and the alerting system built into the OpenShift monitoring system. So Argo CD is what OpenShift GitOps is based on. It essentially deploys a productized version of Argo CD onto OpenShift clusters. And Argo CD provides a number of features if you're not familiar with it. So it does all of the management reconciliation of manifests that are in Git. It basically acts as that GitOps engine. It manages synchronization of all of your desired state from your Git repository into your clusters, be it cluster configuration or applications. It provides that drift detection, visualization, and correction. And the great thing with Argo CD, say in comparison to some other GitOps engine, is it has a fantastic UI to make all of that really easy to work with and understand in terms of, what changed. Not only do you see that, your one particular resource change, you can do a diff and see what's different between what's running in the cluster and what's running in the or what was declared in Git, so you can quickly understand where that difference is in order to address it and remediate it appropriately. You have ability to do rollbacks and roll forwards with Argo CD. Now, I'm a fan of roll forward. I'm not a big fan of rollback, but you can do it with the tool if you prefer that approach. It supports a wide variety of manifest templating tools. So My one tip for anybody that's brand new to GitOps is make sure that you manage your YAML with a YAML management tool like Helm, Customize, JSON. It doesn't really matter what it is, as long as you're doing something. Otherwise, what you're going to find is you're going to have a lot of YAML duplication, and that results in a lot of maintenance overhead and technical debt to deal with down the road. And as I mentioned, the UI provides a very strong visual insight into the sync history and its capabilities. So this slide here is really just kind of showing in a little more detail the workflow that we talked about earlier, where pull requests or direct changes in Git get put in, and then Argo CD can get those changes from Git either through a webhook or it pulls Git periodically. Understand that those changes happen, and then push those changes into the cluster as needed, and it can manage a variety of different clusters as needed. And you can see here a screenshot of what the UI looks like, but we'll go through this in a lot more detail when we actually do the demo. From an OpenShift GitOps architecture perspective, we have the operator, as I mentioned here, that runs on your OpenShift cluster and is managing installations of Argo CD. And every installation of Argo CD is comprised of a few key pods. I don't have every pod in Argo CD's installation here, but the key ones I'm just wanted to highlight here. The first one really is the repo server. This pod is responsible for interacting with your Git repositories. It is what goes out and fetches your manifests, builds the manifest using Helm or Customize, and then makes that available to the application controller, which is this one here, which then interacts with the API server to deploy those manifests onto the cluster as needed. Now, as you can imagine, every time Argo needs to look at manifests and compare it to the state of the cluster, it would be an intensive process to pull this every time, right? So what it does is it uses caching, and it stores the manifests in Redis. If you ever wonder, if you're an Argo user and you wonder what the difference between a normal refresh and the hard refresh is in the UI, what the difference is the hard refresh clears the Redis cache for those manifests and builds them fresh. So all of those manifests are stored in Redis, and it also will store some other things in there as well. And this cache is not persistently stored. Like, you can delete the Redis pod and restart it, and you'll see there's no PVC backing it, and it will just rebuild the cache on the fly. So there's no need to worry about backing up Redis or having any kind of particular operational requirements around managing it. Then you've got the server component. So I mentioned earlier that Argo CD has a really strong UI component. The server component is responsible for delivering that UI. It also provides the Argo CD REST API. So if you want to interact with Argo through a REST API, it provides that capability as well. And then finally, we include DEX with the productized version of Argo CD. DEX is basically used to interact with the OpenShift OAuth engine in order to provide seamless sign-on between OpenShift and our installation of Argo CD. Now, you don't have to use DEX. It's entirely optional. You can also integrate it directly with things like Keycloak if you want to do that, or other OpenID Connect providers. But DEX is available to bridge between Argo, which only does OpenID Connect, and the OpenShift OAuth, which doesn't do OpenID Connect, I think, until it might be in 4.6.16 if I remember correctly, but I'm going by memory, so don't quote me on that. All right, so from a concept perspective, just a few more slides left. Am I doing on time? Pretty good. So in Argo CD, applications are the key component that you're going to interact with when you want to deploy something, be it a cluster configuration or a application, like with a deployment into an environment. And it's really defined by two key pieces of information. You have the source, like, where is my information coming from, my manifest coming from? What Git repository, what path, what revision, like, is it a commit hash, is it a branch, is it a tag, etc. And that's all defined in that source. And then you have the destination. Where do I want to have this thing deployed? Do I want to deploy it in the local cluster? Do I want to deploy it in a remote cluster? And what namespace in that cluster is kind of the key namespace to consider for deployment. Now, that handles deploying the application, but very often, depending on the nature of the application, you may need some additional options and capabilities to manage that synchronization more effectively. And that can be done via the sync policy, where you can provide additional options and capabilities in order to determine how your application is synced. So from a scope of deployment, like, what does the application scope really cover? So an application can be deployed across multiple Kubernetes namespaces, but you can only deploy it into one cluster. So one cluster, but it can span multiple Kubernetes namespaces, even though as part of the application you define a namespace. You can think of that namespace as kind of the key namespace, but there's nothing stopping your deployment from spanning multiple namespaces as long as you have permissions from both an Argo and Kubernetes perspective to do so. The application is, like I mentioned earlier, really the center of the world. That's what you're working with and using on a day-to-day basis in Argo CD. Argo CD has multi-tenancy capabilities, so you can have multiple users sharing the same Argo CD and using Argo CD's built-in role-based access controls, which we'll be talking about a little bit later, to segregate and isolate those users. You can do all of that. Now in Argo CD, there's something called a project that these multi-tenancies are built into, and we'll talk about that in the next slide or two. But the important thing with Argo CD projects, just to keep in mind, is these are not OpenShift projects. They're different than OpenShift projects. The kind for an Argo CD project, a Kubernetes kind, is called an app project. And these projects are not one-to-one with namespace projects. They're completely semantically different thing. So just keep that in mind. I find sometimes people that are not familiar with Argo CD, but have been using OpenShift for a long time, get a bit hung up on the project, which is why I'm kind of mentioning this in more detail here. And just to reiterate again, a project can support applications deployed across multiple namespaces, right? It's not tied to a particular namespace. So projects, we'll look in a little more detail here. An app project really represents a grouping of application. And what an app project really allows you to do is to provide isolation for those grouping of applications. And it's often mostly used to, for example, control who has access to the applications and what things in Argo CD do they have access to in order to do their work, right? So I might have a variety of different tenants, and every tenant on my cluster would have their own application, own app project to manage their applications, right? And that would define things like what repos is that tenant allowed to pull from? What destinations in terms of clusters and namespaces is that tenant allowed to create applications against, right? Maybe they're allowed to create applications in the dev and stage environments, but they're not allowed to do it in prod, for example, right? And then finally, you get a list of roles that define the Argo RBAC to determine what sort of access they have within that project. Can the users just see applications and sync them, or can they do more like create them, delete them, and do different things? So that it can all be defined in the app project as well. Now, in terms of patterns and ways that people organize things, a common pattern that you see in Argo CD is what's called the app of app or application of application. An application, as I mentioned earlier, is really just managing a set of resources or manifests. There's nothing stopping an application from managing, though, a set of application manifests, right? You can just have one application, a root app, and it can have like 20 different applications that it manages. And that's really what an app of app is about. It really allows you to declaratively manage, a group of applications and deploy them in concert in one go. So I can just create the root application, and that root application will then spin up all of the other applications. So for example, for cluster configuration, I'm using app of app extensively, and it makes it really easy because I only need to deploy the root app and everything just flows out of that. You can deliver that in multiple different ways in terms of how you organize it. It can be a collection of application resources in Git. You can have a customization, a Helm chart. I'm using a Helm chart pretty extensively, which we can talk about if folks are interested in that. And you can also have an application set act as a generator for these applications as well, which brings us to the next slide. So app of apps is great, but one of the challenges with it or limitations of it is that it's static, right? You essentially have a static list of applications, although if you use a Helm chart to generate them, you have a little more dynamism involved. What an application set is really designed around is the concept of being able to dynamically generate a set of applications based on inputs provided by various generators. So I can take a application set with a Git generator, point it at a Git repo, and tell it to basically create an application for every directory it finds in the Git repo, right? So if I add a new directory, the application set will automatically create a new application for me, right? So it really allows you to manage your applications a little more holistically, and you can really think of it as kind of a factory for building these applications based on the generator that is being used. In Argo CD, there's a variety of different generators that are available. I mentioned the Git one. A cluster one is another one that's quite common where you can deploy applications across a set of clusters. And they all tackle different use cases, and they can also be used in combination with each other. There are some generators that allow you to combine different generators together, like the matrix generator. So that gives you a lot of flexibility in terms of how you package and use these application sets. And then I think this is my last slide, the role-based access control. So one thing people get hung up with Argo CD and Kubernetes is that Kubernetes has a RBAC layer built into it. Most people are very familiar with it in terms of the permissions it provides: get, view, list, watch, patch, etc. Argo CD has a separate RBAC system. So it also has its own RBAC for managing multi-tenancy, which is completely independent of the Kubernetes RBAC. So it's important to understand that when using Argo for multi-tenant purposes, that you're going to want to leverage the Argo RBAC in order to provide more granular capabilities to your users than what you could achieve with solely just using the Kubernetes permissions for users. So essentially, in Argo CD, it provides RBAC around the resources that it manages, clusters, projects, applications, repositories, etc. And it provides two basic roles out of the box: a read-only role, where Dex is not in the RBAC for Argo. It's really just providing the single sign-on capability, but it's not involved in RBAC at all, if that makes sense. All the RBAC is managed through the I'm answering a question on chat just for people that may not see it. All the RBAC is basically managed by Argo itself, and whenever you interact with the API or the UI, the RBAC is coming into play. If you interact with applications through the Kubernetes command, like if I do a kubectl edit some application, Argo RBAC is not involved at all as well. So you have to keep that in mind in terms of the two layers of RBAC that are being in play and when each one comes into play. Getting back to it, two basic roles: read-only and admin. Admin, as the name implies, gives you full access to everything. And basically, you can create your own roles, though, and assign permissions to those roles, so you can really get fine-grained in terms of what users are allowed to do. And I can show you a bit of that in my home lab if folks are interested in it. So you can define your RBAC in two places. You can define it globally in the Argo CD custom resource, and you can also define it in the projects, as I mentioned earlier, in those app projects. For defining RBAC for tenants, I highly recommend not doing it globally, but doing it in the app projects. The reason being is that the global configuration can get quickly out of hand once you get past a certain number of tenants. Like you get 10, 20 tenants, and it's like, oh my God, there's so much stuff that I'm having to configure in the CR and trying to track it all on a per tenant basis. It becomes very confusing. Whereas if you put it in an app project per tenant and put it in there, it becomes, in my opinion, much easier to manage. All right, so that's the end of my slides before I get to my demo. Any questions before I do a demo? Going once, going twice. Okay. So let's do a bit of a demo here. Can everybody see my screen okay? I'll make that a little bigger. Is that big enough for everyone? Yep.
Yes.
Okay, good. Perfect. Thank you. And Valentina, feel free to keep me honest during this demo. So
I'm sure I don't need to.
So to install the OpenShift GitOps operator, just type in GitOps here. Now, one thing I like to point out is that there are really two operators in play here. There's an Argo CD one, which is the community operator, and there is an OpenShift GitOps operator down here, which is the supported operator. So if you are using OpenShift from Red Hat and you have subscriptions, you need to use this one to get support, which is the OpenShift GitOps operator. If you're using OKD, you will only have this Argo CD one available. Now, the upstream operator for the OpenShift GitOps operator is the Argo CD one, and they share a lot of features. There's a lot of commonality between the two, but there are a few things that we add to the OpenShift GitOps operator that aren't in the Argo CD one. So just be aware that there are some subtle changes. If for some reason you've been using the Argo CD one and you want to switch to the OpenShift GitOps one, you can switch. It's relatively easy, and you can contact your account team. They can put you in touch with me to kind of get into that more detail, but we won't cover it here. But the key is really just to install the OpenShift GitOps operator. So when I go look at my GitOps operators here, my operators that I've installed, I got two, including the OpenShift GitOps one. And you can see I've got a couple of Argo CD instances installed. One for a rollout demo that I'm doing later today. And the one that I'll be using today is the default one that is installed in OpenShift GitOps. So I click on that one. And we can see that it's really just a YAML file where you're defining your installation of Argo CD. So if you remember when we talked about the architecture, the server component, the Dex component, the application set controller, the repo component, and the server one, and everything else is down here. This is all where that gets defined in terms of how you want to manage it and do things. So this is where all that goes. Now, if you're familiar with Argo, you know Argo has a config map called Argo CD-CM, where all of the Argo settings are managed. You do not edit that Argo CD CM directly because the operator will just stomp over your edits and reset it. All of the configuration is done in the operator custom resource. So just keep that in mind as well as you go through things. So that defines an OpenShift GitOps installation. And if I go look at pods here, and we go look at here, you can see all the different components like the application controller, DEX, the application set controller, Redis, repo, server that we talked about in the architecture slide, and they're all running here. And by default, OpenShift GitOps will put a nice little link up here for the default instance in OpenShift GitOps. I can go ahead and click on that. Actually, I've got it running here, so I don't need to click on it. And that will take you to the Argo CD. Actually, let me log out here. So I can log in with OpenShift and using my, let me go get my password off my off screen here. Okay, so I'm logged in and I'm ready to go and start creating applications. Now, one thing just really quickly to show is one thing people get a bit tied up on when they first start with OpenShift GitOps and Argo is that more often than not, the out-of-the-box roles that we define won't work for you because you don't really have any users that meet that criteria. You can see the RBAC is being defined down here. And you can see that there's a cluster admins group that it's expecting to see, and it gives it the role admin. If you're using a managed OpenShift, like Rosa, for example, I think does this, it will define a cluster admins group and put people in it automatically. But on self-managed OpenShift, you won't get this group. You can either create it, or you can just change this group or add new groups to meet whatever you want. You could also change the default policy to be role:admin, but I wouldn't really recommend that in a real world environment because that gives everybody admin access. So just keep that in mind as you're getting going. So I've got my Argo CD here, and let's go through the process of creating an application. So I'm going to create an application, give it a name here of demo. Actually, give it a more, because I'm going to use my product catalog name. We're going to use a project here, default. By out of the box, Argo comes with a default project. For this demo, I'm just going to use the out of the box one. I highly recommend not using the default one ever. As a customer, you should be setting up your own app projects for your use cases and using that and not using default so that you have more control over how that project's configured. But just a little pontification there on best practices. You can set the sync policy, be it manual or automatic. I'm just going to leave it in manual for now as we go through some demos. You can set all of those sync options I mentioned earlier that are available. I'm going to auto create a namespace so I don't have to have a resource to create it. I don't have to define essentially a manifest with a namespace in it. Argo can create it for me based on the destination. And then I need to specify where is my application coming from. So I've got a demo app here that I'm going to use in this repo. We'll copy that, go back here, paste that in. We're going to use the head, the path is just a dot because it's right at the root. And where we're going to deploy it to is next. So the cluster URL, we'll use the local cluster. So kubernetes.default.service is the local API server. And I'm going to deploy it into a namespace called demo. And that's it. I don't think I need to set anything else. Just do a quick check to make sure I'm not missing anything. Fingers crossed, I've got everything. And there we go. So now the application will start deploying. You can click on that. Let me go to the tree view here, and you can see all of the resources that are being deployed. And right now, everything is yellow and being shown as out of sync because it's actually hasn't started synchronizing the application yet. So we'll just give it a second to go through and do that. Now, I tested this yesterday, and of course, you know, the god of demos being what they are, we'll see if I have an issue with this working, but it should be fine. Go on, deploy. Oh, you know what it is? It's got on my manual. Let me sync it. So I'm going to manually sync it here and get it going on the sync. There we go. So now all of these resources will get deployed into my OpenShift cluster, and we'll get the cluster up and running. So you can see here, this product database and this server are taking a bit more time from a deployment perspective, and we get the progressing here. Argo CD understands the health of resources and provides a lot of out-of-the-box health checks on these resources, which let it understand the state of that resource. Is the resource working as anticipated? Is it in the middle of doing something, i.e. the progressing status? Is it broken, which will give you the degraded status? And you can see the statuses that are available down here. In fact, I can see I've still got one progress. Nope, now we're done. So this is all deployed now, but those health checks are really important to leverage some of the more advanced features. And I always like to highlight it too, because it's essentially free monitoring. In OpenShift, we provide monitoring around OpenShift GitOps in terms of whether your application is healthy and whether it's synced. If you have health checks for all your resources and it goes into a degraded state because of that health check, that will get bubbled up into your alerting automatically through Argo CD, right? So you essentially get that kind of a monitoring for free by having your resources being managed by Argo CD. Now, if I go look at my application here, log in again, admin log me out. Let me copy my password again off screen. We'll go look at the demo namespace, and we'll switch over to the developer view for a second. Skip tour, topology. So you can see my application is deployed now, right? It's really just a 3-tier application with a Node.js front end, a Java backend, and a database that is running the backend. If I click on this link, I fixed a bunch of CORS issues yesterday. Yep, still working. You can see it's a simple product catalog application, nothing too fancy, right? So it's all deployed. Everything's good. Let's say, for example, Bob, who doesn't really know what he's doing, comes in here and says, you know what, I'm just going to delete this deployment. We'll just delete that. Now, if I go back to Argo CD, we can see, hey, it's out of sync. And you can look and see, what's out of sync? The client, right? And then click on the client and it can do a diff. You can see here that, oh, what's in the cluster is non-existent. There's nothing there. And what should be there is this manifest on the right side. So I can go ahead and press the sync button again, and we can go ahead and automatically synchronize that. And if we go back here, topology, you see it's back, right? Similarly, if I go here and I change the replicas to say 3 replicas, we'll see here that's back to out of sync. You can see it's healthy, but it's out of sync. And again, if you go to the diff, we can see exactly, oh, sorry, it's what changed here, right? It's the replicas. I've got 3 in terms of my state on the cluster, but my desired state is 2. And I can, again, click the sync button if I want. But what I can also do is if I go down here, I can enable auto sync. And that should do it. Should not need to press the sync button here. Did I do that right? Oh, I didn't enable the self-heal. Enable the self-heal. There we go. So when self-heal and auto sync is enabled, it will automatically remediate those changes, right? So now I'm back in sync. And if I go look here, you can see my replica count is back to 2, right? So Argo is really just is actively managing those resources on your behalf and making sure that those resources are always aligned with what the desired state is in Git that you declared. Any questions on this so far? Okay. You can leverage more advanced features in here. So for example, I've got pods right there. Click on pods. And in the UI, for example, you can see the logs if you want to. I'm not sure. I might not have the permission enabled in this demo, but there are other things that you can enable in here as well as a terminal. We do have some customers that, for various reasons, prefer their developers to manage their applications in the Argo CD UI versus the OpenShift console. And so they get a lot of capabilities to do that out of the Argo CD UI as well. But that's really just a taste of the UI. And hopefully that really just kind of highlights the capabilities that Argo has. Now, you get more advanced. I'm going to go through it right now in great detail, but just to show you on my home lab environment here, if I go to my cluster one and log in with Keycloak, you can see all of my different applications here, right? I've got 29 applications, and these are all my cluster configuration that is going on here, right? So I've got a compliance operator deployed, the cost management operator deployed, external secrets operator deployed, a bunch of different things deployed, all being managed by Argo. And it's the same across all my different clusters, right? So just as an example to show you kind of what it looks like once you get a lot of things deployed and are managing that more actively. And as I mentioned earlier, you can segregate things into different projects, right? So my cluster configuration here is in a cluster config project, and my Bootstrap is in a Bootstrap project, and then demo, I just had an ad hoc project. I also have another one for tenancy. So these are this cluster one is the one that the platform team is using to manage clusters. The shared one is the one that is designed for teams. I'm logged in as the cluster admin right now, but if I go look at my settings, my projects, you can see I've got 2 projects here, one for each tenant. Product catalog is one of my tenants. Rollouts is another one. If I click on the product catalog, we can see here that I am limiting the product catalog team to these namespaces, these destinations specifically. In terms of roles, I give them a certain amount of capabilities, like the product catalog admin. He is allowed to view applications, and actually I got them on the create applications as well. But the users one is more locked down. They're only allowed to get and sync applications. So if they're a user on that team, i.e. just a normal developer, not the administrator for that team, then they have very limited rights in terms of what they can do in Argo CD. And if I were to log in as the product catalog user, I only see the product catalog apps. And if I log in as the rollouts user, I only see the rollouts apps. So that's a really very quick overview of what OpenShift GitOps is about, with a bit at the end here about kind of more advanced use cases and some of the things that you can aim towards as you're embarking on your GitOps journey. I don't have anything else to show at this point in time, but I am happy to take questions or go through more detailed use cases. If folks want to see different things, just let me know. So I'll pause here.
No, this was great. Thank you. Any questions for Gerald? This was great. So yeah, I'm very passionate about Argo. When I started doing some like simple demos with applications, and lately I've been working a lot with Backstage, which works really well. And of course, the Red Hat Product Developer Hub works really well with GitOps. The main idea is that you create those software templates or content templates to define all the applications manifest, from pipelines to deployments, and all of that is managed through GitOps. So I am such a fan of just, GitOps will manage all the state, as you were saying, Gerald, of the components, to ensuring that the cluster is always in that desired state that I want. But I know that also, Gerald, you're, and I've been doing some of it, but you've been doing a lot more than I, on using also GitOps to set up like cluster setups and configurations such as operators. Do you want to talk about that a little bit?
Yeah, sure. So that's the this GitOps one, and it kind of goes back to what Dan was asking about in terms of ACM. I think it was Dan asking about ACM and Argo. So I use the two together to manage my home lab. So if I go to my ACM cluster here, my hub cluster, I'll switch to the ACM view. Go on governance. So I have a GitOps policy set that I use that is used to bootstrap OpenShift GitOps operator, as well as the bootstrap application onto my different clusters. So basically, from a policy perspective, it has policies for deploying the OpenShift GitOps subscription, deploying the bootstrap application, which is the app of app, as well as updating the OpenShift GitOps instance for the configuration that I need for the stuff that I'm doing. And in terms of tying that to that policy to clusters, the way it works, if I go to a cluster here, you can see here there's a label. Let me make that a little bigger. You know what? Let's go down here and see the labels. There we go. Right here, this GitOps local.home. So any cluster that has the GitOps label on it will automatically get that policy deployed. And what it's equal to is used by the policy to determine which cluster configuration gets deployed on that cluster. So in this case, it's using the local.home configuration. And that will essentially use the Bootstrap application for that one. That Bootstrap application is really, if I go up back to Argo, and that one cluster is this one here. And what it does is essentially uses an app of app pattern to deploy all of the applications that are needed for the cluster configuration, right? So you can see things, for example, like I said, the cost management operator, the container security operator, the pipelines operator is in here somewhere. There it is. This is a single node OpenShift cluster, so I'm using LVM for storage, the LVM operator, so deploys that as well. And it's managing all of that. And it does that through using sync waves. So sync waves are a capability in app of app that allows you to organize the order of applications that you want deployed, and it will not move on to the next application until that one is done. So the first thing I'm deploying here is my external secrets, because all of this other stuff needs secrets, and it's using the external secrets operator to access all of that. Then I deploy the storage, which is the LVM, and then certificates. So the API certificate and the ingress certificate get managed by Cert Manager. So that gets deployed by the Cert Manager operator, and then the certificates. Configure authentication, the registry needs to be updated to use the LVM storage, and a few other configs to it are needed to be made, and so on and so forth, right? And it just continues upwards, and this all rolls out automatically. So as soon as that policy, that ACM policy gets applied and the OpenShift GitOps operator is installed by ACM on that cluster, along with that bootstrap app of app that I'm showing here, the rest of the cluster configuration just flows naturally from that, and everything gets deployed and configured.
Nice. Love
Is that-
those. Yeah. Dan, I think Dan had a question. Yes, go ahead.
Yes. So since we're all Red Hat here,
We are recording as well.
Well,
Do
we
you want
are
me
recording so
to?
other people, non-Red Hatters, will see it. So just keep that in mind.
okay. So
But I can stop it, if you guys want.
so the GitOps functionality is part of it starts at the Platform Plus level, correct? I don't see it in OKE or standard.
So OpenShift GitOps is included in OpenShift. There's no additional subscriptions required. And if you want to do multi-cluster configuration with just Argo CD, you can absolutely do that. But having said that, I do find that ACM, putting that in the mix, does add a lot of benefits to managing OpenShift GitOps effectively and providing additional capabilities that Argo CD does not have. So the two, like I said, are really complementary to each other, and I prefer to use both for managing a fleet of clusters.
Yeah, no, I guess to ask the question differently, GitOps functionality is included in OpenShift, but it starts at the OpenShift Platform Plus, that you have that as part of the offering.
Right. So for the demo that I just showed you, it starts with Platform Plus in the sense that there's a policy that manages the installation of OpenShift GitOps across all of my different clusters. But that's not tied to subscriptions or anything of that nature, right? It's just how it flows technically.
Okay. I thought that was one of the differentiators between OKE and, say, standard was Platform Plus.
Well, I don't know about OKE. I can't remember off the top of my head exactly what's included or not. I'm referring more to standard OpenShift, so non-OKE. I think GitOps is an OKE, but I would have to double check just to make sure. And you can go check. There's a page that lists all the features that are in or not. The challenge with OKE, as you know, is that OKE, packaging wise, exactly the same as normal OpenShift. It's just a limitation on customers not to do things, even though the features are all the same and the packaging is all the same between the two. It's the exact same product, right?
Okay. Yeah. No, I understand.
Yeah. The other nice thing too with ACM, hopefully this actually works, because I'm in the middle of, I did an upgrade to 4.16 there the other day, and I'm just dealing with a few minor issues, is you can have dashboards. And, you know, I've got a custom dashboard in here that I built out, which manages all of my GitOps information across my fleet of clusters, right? So I can see, it's broken right now because I'm having some issues with observability on my my managed cluster with the upgrade to 4.16, which will be sorted out hopefully soon. But you would see all the different clusters that are being managed that have Argo CD installed on them, how many instances there are. Get a thumbnail view here in terms of, you know, what the status are, as well as these pie charts. You can see the different application statuses, sync status. And this goes fleet wide, right? So you can see all the Argos from this one pane of glass in terms of their statuses and what's going on with them. So that's another kind of feature that ACM provides with observability that is quite useful once you start operating Argo at scale.
Nice. I share the link also about all the comparisons about the different OpenShift. I don't see GitOps included, but something, yeah.
You know, key, you mean?
Mm-hmm. Yep.
Okay.
Yes. Okay, any other questions? I can stop also the recording. Thank you so much, Gerald. This was fantastic. I will see everyone next Wednesday. I will stop the recording here.